For decades, we thought we fully understood the edge of our solar system. A distant, gradual fade into darkness, a slow thinning of the sun's influence until nothing but empty space remained. That was the image. Clean, predictable, almost comforting. Then Voyager crossed the boundary. What it detected was no gentle transition. It was no smooth handoff from the sun to the galaxy. It was abrupt. Plasma vanished. Cosmic rays surged. Magnetic fields shifted direction like a compass snapping to a new north. It felt as though the spacecraft had passed through an invisible membrane dividing two entirely different cosmic regimes. But that was only the start, because beyond that boundary, Voyager 2 detected compressed plasma layers, shifting magnetic fields, and an alignment so precise it implied our solar system might be embedded within something far larger than we had ever imagined. A structured region, a cosmic bubble, a boundary that serves not merely as a limit but as a dynamic interface between opposing forces. And long before it reached that frontier, Voyager had already rewritten everything we believed we knew about the planets themselves. Volcanoes on Io, lightning on Jupiter, a hexagon on Saturn, geysers on Triton, a twisted magnetic corkscrew at Uranus. This was not merely a probe drifting into darkness. This was humanity's messenger venturing into a region no spacecraft had ever measured before. And what it discovered at the edge changes everything. Let's begin with the crossing itself. When Voyager 2 drew near the outer boundary of the heliosphere, scientists expected a gradual fade in solar influence. Instead, the instruments recorded something startlingly different. The solar wind, a steady stream of charged particles flowing outward from the sun, did not slowly diminish. It dropped sharply almost instantly. At the same time, energetic cosmic rays from outside the solar system surged. These were not particles born from our sun. They were galactic, high-energy messengers from distant supernovae and violent astrophysical events across the Milky Way. The spike was unmistakable. A new region had been entered. Then came a magnetic shift. The orientation of the magnetic field changed distinctly, confirming that the spacecraft was no longer inside a solar-dominated environment. This was not speculation. It was measurable. Particle densities changed. Plasma characteristics shifted. The rules governing the environment had flipped. It was as if Voyager had crossed an invisible wall. Not a visual wall, but a physical one. The expectation had been simple. The heliosphere would gradually fade into interstellar space, a blending of environments, a smooth transition. But Voyager revealed that the boundary is narrow, sharp, and highly defined. The spacecraft detected a clear transition between the hot, sparse heliospheric plasma and the colder, denser interstellar medium. There was no long gradient, no gentle merge. Instead, the difference between the two environments was abrupt enough to challenge long-standing theoretical models. Even more surprising, Voyager 2 found that beyond the Heliopause there were extra layers, regions of compressed plasma and shifting magnetic structures. The edge of the solar system was not a simple line. It was layered, structured, complex. And that complexity suggested something profound. The solar system does not dissolve into the galaxy. It meets it, and that meeting point is far more dynamic than anyone had imagined. When Voyager 2 crossed into interstellar space in November 2018, it carried something its twin no longer possessed at that stage: a functioning plasma science instrument. That single detail changed everything because it allowed scientists to measure the plasma environment directly instead of inferring it indirectly. And what those measurements revealed was not a simple boundary, but a layered structure beyond the Heliopause. Instead of a clean separation between solar territory and interstellar territory, Voyager 2 observed extra layers just outside the heliosphere. Regions of compressed plasma and shifting magnetic fields that made the edge feel more like a dynamic interface than a dividing line. The plasma density did not behave exactly as expected. The temperatures beyond the termination shock were lower than models had predicted, and the spacecraft measured streams of high-velocity particles and non-thermal pickup ions that suggested far more complex particle behavior than anyone had assumed. This was not the image of a neat bubble floating quietly in empty space. It was a structured, pressurized boundary zone shaped by forces pressing inward from interstellar space and outward from the sun. The heliosphere was not simply fading into nothing. It was interacting, responding, compressing. The edge of our solar system turned out to be an active region, not a static shell. And that led to a deeper realization. If there are layers, compression zones, and structured magnetic transitions, then we are not drifting freely in an infinite void. We are enclosed inside something defined, something shaped, something under pressure. Perhaps the most unsettling discovery came from the magnetic field measurements. Beyond the Heliopause, Voyager 2 detected that the interstellar magnetic field aligned startlingly well with the heliospheric magnetic field. Instead of a chaotic mismatch between solar and galactic domains, there was coherence. The orientation did not twist violently. It continued in a surprisingly ordered fashion. That alignment suggested that our cosmic neighborhood is more structured than previously believed. The sun's magnetic influence and the galaxy's magnetic field were not colliding randomly. They were interacting in a way that hinted at large-scale organization. The boundary between them was sharp, yes, but magnetically there was continuity. At the same time, Voyager 2's crossing of the termination shock occurred about 1.6 billion kilometers closer to the sun than Voyager 1's crossing, revealing that the heliosphere is not symmetrical. It is dented, compressed by interstellar forces. That compression tells us that the galaxy is pushing back. Our solar system's protective bubble is shaped by external pressure. When you combine the layered plasma structures, the compressed boundary, and the unexpected magnetic alignment, a new image emerges. Not a fragile system fading into space, but a solar bubble embedded within a larger magnetic environment. A region carved out by the sun, but sculpted by the galaxy. And that changes the way we see our place in the cosmos. Long before the edge of the solar system revealed its secrets, Voyager had already begun dismantling old assumptions. When Voyager 1 reached Jupiter, the largest planet in our system was thought to be a massive, but relatively simple gas giant. What it revealed instead was a world alive with motion, energy, and violent processes. The spacecraft photographed swirling belts and zones painted in rusty reds and creamy whites. Not static bands, but dynamic atmospheric systems in constant motion. It detected lightning for the first time beyond Earth, capturing radio signals known as whistlers and flickers of light on the planet's night side, where clouds were being electrically discharged. Jupiter was not calm. It was electrically active. Then came Io. Voyager 1 captured active volcanic eruptions, plumes of sulfur dioxide and lava flows reshaping the moon's surface. It was the first time volcanic activity had ever been observed on another world. In a single flyby, the idea of a geologically quiet outer solar system collapsed. Jupiter also turned out to have a faint ring system, something previously associated only with Saturn. And when Voyager mapped the planet's magnetosphere, it found a magnetic field far stronger than expected with intense radiation belts filled with charged particles racing through space. This was not empty planetary territory. It was hostile and dynamic. Then came Saturn, winds blasting at nearly 1,100 miles per hour near the equator, alternating east-west jet streams, and the hexagon at the North Pole, a six-sided jet stream roughly 29,000 kilometers across, perfectly shaped, defying simple atmospheric explanation. Saturn's rings were revealed in unprecedented detail, composed of countless icy particles forming intricate ringlets, gaps, and even ghostly spokes that appeared and vanished over time. The outer planets were no longer distant static spheres. They were laboratories of extreme weather, electrical storms, and magnetic violence. And that was only half the journey. Unlike its twin, Voyager 2 continued outward, becoming the only spacecraft in history to visit all four giant planets. When it reached Uranus in 1986, it found a world stranger than anyone anticipated. Uranus's magnetic field was tilted about 59 degrees off-axis and not centered within the planet, creating a corkscrew-shaped magnetic tail stretching millions of kilometers into space. It was unlike any magnetic field ever measured before. Voyager 2 also revealed that Uranus is the coldest planet in the solar system, averaging minus 320 degrees Fahrenheit, with virtually no detectable internal heat. Yet it showed heat transfer from pole to pole, keeping cloud-top temperatures similar even though only one side had been illuminated by the sun for decades. Its faint dark rings were imaged for the first time, and 11 new moons were discovered during the flyby. Then came Neptune in 1989. Voyager 2 captured the Great Dark Spot, a massive storm roughly the size of Earth with winds screaming it up to 2,100 kilometers per hour, the fastest ever recorded in the solar system. A second storm appeared as well, and a fast-moving bright cloud nicknamed Scooter raced across the upper atmosphere. 6 new moons were discovered, including Proteus, a dark, heavily cratered body shaped like an irregular polyhedron, and then Triton. Neptune's largest moon revealed geysers erupting dark nitrogen plumes into space, a thin atmosphere, and polar caps. Despite its extreme cold, it was geologically active, defying expectations once again. By the time Voyager approached the edge of the solar system, it had already rewritten planetary science. Volcanoes beyond Earth, lightning on gas giants, hexagonal storms, tilted magnetospheres, supersonic winds, active moons in the frozen outer dark. The solar system we thought we knew in 1977 did not survive Voyager's journey. And yet what it would find beyond the planets would prove even more unsettling. Before either spacecraft even left Earth, NASA made a decision that transformed the mission from exploration into something far more profound. Mounted on both probes was a 12-inch copper disc plated in gold. Not scientific instrumentation, not hardware for navigation. A message, the golden record. It was designed as a time capsule, a message in a bottle cast into the cosmic ocean. If one day another intelligence were to encounter these spacecraft drifting between the stars, they would not find silence. They would find us. The record contains the sounds of Earth, surf crashing against the shoreline, thunder rolling across the sky, birds singing, whale songs echoing through deep water. It includes human sounds, footsteps, heartbeats, a kiss, even brain waves recorded while contemplating fear, love, and anxiety compressed into a single minute of audio to capture the emotional spectrum of humanity. Music from across cultures and eras was included. Beethoven, Mozart, Bach, Chuck Berry's Johnny B. Good, African drumming, Peruvian wedding songs, electronic compositions. Greetings in 55 languages from ancient Akkadian to modern Chinese, a message from the United Nations Secretary General, even a personal greeting from child. And then there are images, 116 photographs and diagrams. Human anatomy, DNA structure, architecture like the Taj Mahal and the Golden Gate Bridge, Olympic sprinters, a silhouette of a couple, instructions for how to play the record, a map showing how to locate Earth. It was an extraordinary act of optimism to send not just data about planets, but a portrait of who we are. And now that portrait has crossed into interstellar space. Both Voyager 1 and Voyager 2 are now beyond the heliosphere, drifting into the interstellar medium. They will take about 300 years to reach the inner edge of the Oort cloud and another 30,000 years to pass through it. Long after our current civilization has changed beyond recognition, the spacecraft will continue moving outward. They carry with them the discoveries of Jupiter's lightning, Io's volcanoes, Saturn's hexagon, Uranus's twisted magnetosphere, Neptune's violent storms, Triton's geysers, and the measurements of compressed plasma and magnetic alignment at the solar system's boundary. But they also carry the golden record. That disk will orbit the center of the Milky Way for hundreds of millions of years. The spacecraft will outlive mountains, oceans, perhaps even species. Untouched by the events that reshape Earth, they will travel silently through the galaxy, bearing a memory of a world that may no longer exist in its current form. And that is perhaps the most powerful realization of all. We did not just send instruments to measure the edge of our solar system. We sent ourselves, technological civilization, reaching outward, crossing a boundary we did not fully understand and leaving behind a trace of who we were. The edge of the solar system is no longer just a scientific frontier. It is a human one. When we launched Voyager 1 and Voyager 2 in 1977, we thought we were sending probes to study planets. Jupiter, Saturn, maybe if we were lucky, the outer giants. What we actually sent was a pair of witnesses to the structure of our cosmic home. They revealed volcanoes erupting on Io, lightning flashing across Jupiter's night side, Saturn's hexagon spinning like a geometric storm carved in a gas, Uranus's magnetic field twisted into a corkscrew, Neptune's wind screaming at over 2,000 kilometers per hour, and geysers erupting from Triton in the frozen dark. They showed us that the outer solar system was not silent. It was alive with physics. And then they kept going beyond the planets, beyond the Kuiper Belt, toward a boundary we had only theorized about. And when they reached it, the data didn't whisper. It snapped. Solar wind vanished. Cosmic rays surged. Magnetic fields shifted. The transition between heliospheric plasma and interstellar medium was sharp, narrow, undeniable. The edge of the solar system is not a gradual fade into nothing. It is a structured frontier, a compressed boundary, a layered interface shaped by galactic pressure. The heliosphere is not a perfect sphere. It is dented, shaped, aligned magnetically with its surroundings in ways we never predicted. We are not floating freely in empty space. We are inside a solar bubble carved out by our star and sculpted by the galaxy. And drifting through that frontier, beyond our protective shield, is a golden disk carrying the sounds of our oceans, our music, our languages, our biology. Voyager did not just detect plasma shifts and magnetic alignment at the edge of the solar system. It revealed that our home has a boundary, that the galaxy presses back, that the void is structured, and that we chose to cross that line anyway. The edge was never the end. It was the beginning of understanding where we truly exist. If this journey changed the way you see our place in the universe, make sure you subscribe because Voyager may be billions of kilometers away, but the story of what lies beyond our cosmic bubble is only just unfolding. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.